Right. Thank you, everyone, for joining in. We are doing the episode 4 in the year 2017 of the vRealize Operations webinar series. Today, we are going to talk about workload placement or optimizing workload performance using automation. Essentially, if you look at the graphic on the screen, you'll see a bunch of rocks trying to balance and trying to stay at where they want to be. And that's essentially possible because they're supporting each other, and somebody who's placed them has placed them in a fashion that they're able to get enough balance or enough resources that they require to stand and to balance themselves on that picture. So we are just trying to imply this into a data center as well today and see how we can use the concept of balance and concept of predictive placement to ensure that your workloads can get what is required from a performance standpoint. We'll quickly run through the housekeeping items. I see still people joining in. Let me just go to. If you've just joined in, any question and answers will be done through chat in the beginning of the session. We'll answer questions at the end of the session by opening up the phone lines. So use your chat window to ask any questions, and we'll answer them as we go along. The session is getting recorded and will be posted on our blogs as usual, and you'll also have a recording up on YouTube. All participants are on mute, so we just want to make sure that we are recording it clearly for users to have the session or review the session later on. And if you have any questions, again, use the chat window. There's a feedback form or survey, which is up there on that link. And we always appreciate your feedback. We've got some great feedback from the past sessions which we have done, and we want to make sure that we're listening about the topics or hearing from you in terms of what topics you would want to hear from us and what other operational challenges you have so that we can go ahead and give you solutions to those specific use cases. As usual, we are the prime suspects. My name is Sunny. I work for VMware as a senior member of technical staff for the Cloud Management Business Unit. And with me, I have Simon. Simon, would you want to introduce yourself?
Yeah, sure. As you can see, my name's Simon Eady. I work for a company called Extrovert. We're a consultancy based in the UK. We do lots of VMware work, PSO work with VMware, and I work as a senior consultant for them.
Awesome. Thank you, Simon. Simon will be helping me today with answering questions. And we do have a guest speaker today, and I would like you to give a big round of applause for Jad. And Jad, I don't have the clapping music, but welcome, buddy.
Oh, you couldn't find the matching font, huh, Sonny?
I could.
How much did we spend on that? Hey, everybody. So, Jad Alzane, thanks for having me. I'm a principal architect in VMware's Cloud Management Business Unit, primarily focused on vRealize automation. So there's just a couple of things I'm going to be chiming in on during this presentation, but also answering questions with Simon in the back end as needed. But thanks for having me. Love doing this stuff, and look forward to more.
All right. Thank you so much, Jad. Thank you. I'm sure everybody who's joined in would appreciate your inputs around automation as well as operations. All right, so let's kick it off. So today, or if you remember the previous session, or if you attended the previous sessions or heard the recordings, you would know that we started the theme of talking about vRealize Operations 6.6 as a product. And more than looking at the product feature set, we were focused on what are the various different use cases which are solved with this specific release, and how you can incorporate vROps into day-to-day operations or operational procedures you might have in order to solve specific use cases. Today, we are kind of moving ahead from manual operations and talking about certain specific use cases which are delivered through a feature called Workload Balance. Now, Workload Balance was introduced with vROps in the older versions, but essentially what we heard and learned from customers was that we want to make sure that we are able to go ahead and automate a lot of day two operation or operational stuff, which admins have to do on a manual basis, keeping a track of a bunch of resources, and it becomes highly difficult for them to operate in that fashion. And hence, with vRealize Operation 6.6, we had a fully automated workload balancing feature which was available to solve a bunch of use cases. And essentially, there were four essential use cases which were associated with workload placement or workload balance. To begin with, we wanted to make sure that if you're running an application on a virtual infrastructure, then you're responsible to make sure that that application is being served well. In order to ensure that the application is being served well, it is essential for you to know and understand the demand patterns of those applications. Now, those demand patterns may vary depending upon the business cycles or depending upon where that particular workload is running or what exactly is that serving from an application point of view or from a business point of view. Now, keeping all these priorities in mind for a human being is impossible when you're running thousands of virtual machines. And hence, we wanted to make sure that we kind of take out all these complexities from the hand of the VI admin or virtual infrastructure administrator and codify it in such a way that virtual machines can be placed in a specific location in your data center where they can be served well. And if there comes a time then they require more resources and those resources are not available in their existing location, then those virtual machines or applications can be moved across to a different location where you might have resources available. And that's the whole notion of how we can do proactive performance management without somebody manually intervening or clicking buttons on a day-to-day basis. That's workload balance in a gist. Now, essentially, if you deep dive further, there are multiple use cases which can be solved through this. There could be use cases around day zero, where you want to figure out that when you create a new virtual machine or a new set of applications in a data center, where do you place them so that they get the best performance from day number one? And then there are other use cases around how do you manage the life cycle of those virtual machines and applications where they demand different performance patterns, and at the same time want to make sure that whenever they're demanding those patterns, they're being served well from a data center standpoint. That's another use case. Now, if you look at the personas which are being targeted here, are pretty much the virtual infrastructure admins or the cloud admins. Now, these are the people who are dealing with day-to-day movement of virtual machines. If you are a VI admin or if you've ever met a VI admin, you would always know that they've always been tasked about moving virtual machines from one host to another, one cluster to another, one data store to another data store, just trying to cut the corners to ensure that they're able to manage within the resources they have at most number of times. And that is to suppress or take care of any ongoing fire in the data center. Now, this essentially leads to two problems. One is that it wastes a lot of time because they have to invest in figuring out where do they have resources and then move virtual machines. And then the second is that this is a very reactive approach to what they're doing as compared to where they want to be, and which is proactive essentially. And in order to make sure that we are able to solve these two use cases of making sure that we can move automatically without wasting time and plus make sure that the performance is taken care of, it was important for us to look at the entire infrastructure right from vSphere, from a vSphere architecture standpoint, and build a common framework or a rule engine which can help us define business policies, define your availability policies, and at the same time, understand what would be the best way to place your virtual machines. So that's essentially, in a nutshell, is what workload balance is and the kind of answers it provides to you as a VI admin. Now, me, Jared, and Simon were thinking about or talking about what do we discuss with customers and what our customers are really solving from a use case standpoint when it comes to placement. And essentially, if you look at the industry and if you go in being a consultant or being a customer yourself, if you look at your environment, essentially if you look at environments which are large or let's say medium or large in size, is where they get into the complexity of not having a complete visibility into where those resources are in the data center, because they're usually fragmented, and at the same time, you do not have a way to understand the entire workload pattern of your entire data centers or workloads which are running in your environment to ensure that they're placed in the right place at the right point of time. Now, this brings up three initial use cases which we want to talk about today, and we'll showcase how exactly these use cases can be solved through vRealize Operations Manager and other products in the vRealize suite working together. So the first use case is around taking care of your availability policies. Now, you all will agree and understand that when you started virtualization, you started with a very basic fundamental feature, which was vMotion. I mean, we call it basic and fundamental now, but back then it was a killer feature. And vMotion essentially is the reason why people virtualized at first go, because they wanted mobility to be available to virtual machines so that they can move across whenever they have to do DR or take backups or do snapshots and so on and so forth. Now, this vMotion in tandem with DRS, which is Distributed Resource Scheduler, actually does the magic of making sure that when a machine requires certain resources, it is being fulfilled by moving those virtual machines within a cluster. Now, this happened way back when we started with virtualization. So you have a virtual machine or a bunch of virtual machines sitting in a cluster. That cluster is enabled for DRS, and those hosts within that cluster are enabled for vMotion. And essentially, if there is a problem or if there is a contention which is faced by a virtual machine on a given host due to a high demand situation or due to underlying resources being constrained, the virtual machine will automatically move across to a different host to ensure that that virtual machine is being served well. Now, that's the story of within a cluster. Now, essentially, over a period of time, as you expand your environments and go from one cluster to 2 clusters to 10 clusters, and then go from 1 vCenter to 20 vCenters, and so on and so forth, you start having a configuration drift from your DRS policy standpoint. And that configuration drift is kind of hard to manage if you're looking at each of your vCenters and going ahead and checking the settings of each of your vCenters. Now, what we solved, the first problem we solved with workload balance or workload placement, this vROps, was to bring all that configuration in a single screen for you so that you can visualize and understand whether your base vSphere architecture and base vSphere configuration policies around placement of virtual machines within a cluster are configured properly or not. And that is what you can do with DRS. So you can do with workload placement. So basically to manage DRS from a single pane to understand how it is configured, and if it is not configured properly, then how you can go ahead and remediate it. So those two use cases are covered in the first bullet point, which you see here. The second bullet point is once you have managed your DRS clusters and you're making sure that the virtual machines can move around within that cluster without any issues, we look into a situation where what happens if a cluster itself is full. So imagine you have 2 clusters. One cluster, and both these clusters have DRS fully automated. Now, on the first cluster, you're kind of running out of resources, and at that point of time, DRS would really not be able to do much for you because the role of the DRS, or the boundary for DRS, is a cluster compute resource or a cluster object. It cannot move a virtual machine beyond cluster in an automated fashion. you would have to manually come and find virtual machines, find the location where you can move them and start those migrations. Now, that's where we come in and we use vROps to ensure that we can move these virtual machines across clusters from one cluster to another in an automated fashion by keeping check of resources in the source and the destination clusters. And while we are doing all this, we also make sure that we take care of your business priorities and availability policies, which you might have configured for those virtual machines. And we'll talk about what those business priorities or configuration policies could be as we move forward today. So that's the second use case. Now, while you want to do this in a manual fashion as you begin, because anything which you automate, you should have done it 10 times at least in a manual way, and then you automate so that you can get the confidence. So we allow you to do both of those. So first you go ahead and run it in a manual fashion, and then once you're confident enough to run those rebalance or movements across clusters, then you can go ahead and fully automate it as well. We'll kind of talk about it and showcase that in a demo today. The third use case where my friend Jad comes in, and I'm sure Jad can speak better on this use case than me, and he will when we move on further in the slide deck, is around the notion of how do I start or where do I start my virtual machine or the life of a virtual machine. What would be the correct place to start a bunch of applications which I'm giving to my business and I'm serving in terms of an IT operator, and making sure that they're placed, powered on, and initiated at the right spot. And in order to find that spot in your data center amongst all the fragmented resources, you need to find out a way by which tools such as, or provisioning systems such as vRealize automations can understand where do I power on and place this virtual machine when it's first created or at its inception. Now, that's a very powerful notion of making sure that you're able to take care of your historical, or making sure you're able to utilize your historical data to make decisions such as these, rather than leaving those decisions on somebody who's provisioning those virtual machines, whether it's a human being or it's an automated provisioning engine such as vRealize automation. So that's the kind of third use case which we are going to talk about and showcase today. Do you want to talk something about that, Jack? Or did I do justice to your topic?
That was good, and then we'll cover it more when we get to those slides.
Okay, awesome. Thank you, sir. All right, so let's look at the first use case around DRS management, right? And we will look at the demo as well in order to kind of look at all the settings. I just want to quickly cover up the slides so that we can actually get to the demo, which has been the kind of theme with this webinar series. And let's just quickly look at what you can do. So essentially, this is not the whole page, but I have a few screenshots which can show you that I could have an immediate glance of what's going on at each of my data center as well as cluster levels. And this is across all my vCenters, which I'm monitoring through the single vROps instance. And what you can do is you can view your DRS settings, understand what they are. You want to make sure whether they match your business needs or not, and you can go ahead and modify them and write from vROps itself. So what basically means is you don't have to really log into that remote vCenter, which is running in Siberia, and make those changes. But if you have a single pane of glass, such as vROps with this workload balance page, then you will see all your clusters, all your data centers clusters which are being monitored, and you can make those changes right from here. And they'll be, and the action frameworks within vROps will go ahead and make those changes for you back in those vCenters. So that's one of the options that you have. Now, the other thing which we keep a track of is the churn of vMotions which are happening in an environment. Now, there are two use cases associated to it. If you are doing too many vMotions, now you would agree that that's not a healthy environment as well, because if you're moving too many VMs across every minute, then you might be running into a situation where your virtual machines are ping-ponging amongst or between hosts because of certain or resources being contended for, or it could be because of a configuration issue. Now, those are things which we kind of try to monitor by making sure that we can give you a trend of how virtual machines have been moving in your data centers and in your clusters. And that's a part of this particular page. So that's one side of the problem. The second side of the problem is you also want to make sure that your vMotion configuration is configured properly. And if you do not see any vMotions happening in your environment, then this is a good indicator of the fact that either your capacity is not being, or your clusters are not full, or it could be that your vMotion configurations are not done correctly, which are both bubbled up into vROps out of the box. And we can look at some of those settings when we go into the demo. So this is around DRS management and DRS control. I told you about the importance of DRS and how this particular solution helps you solve that problem, which is faced by a lot of medium and large customers today. All right. Now, once we move from DRS, let's just jump into workload balance and see how we can actually start automating things to ensure that you're getting proactive performance for your applications or workloads which are running on top of a vSphere environment. Now, essentially, if you look at the whole notion of DRS or DRS or workload balance is at the end of the day that you want to make sure that your VMs are happy. Imagine me and Ivan, whom you might have heard on this webinar series before, talk about an analogy of a restaurant business. In a restaurant business, you have a dining area, you have a kitchen, right? And no matter how good your kitchen is, if your customers in the dining area are not happy, then your business will go down. Same goes with VMware business as well, or let's say if you're providing infrastructure as a service to your customers, it could be an external business or providing services within your organization. Now, at the end of the day, you want to make sure that virtual machines are happy and the applications which are riding on those virtual machines are happy. No matter how good or fast your infrastructure is, unless the VMs are happy, you'll not be doing good, or your CIO might not be really a happy guy. So at the end of the day, what we take care of with both DRS and workload balance is to ensure that virtual machines get what they need and we move them across wherever they can get the best resources possible to serve a workload need. Now, that's what we do. Now, there are a couple of things which we go ahead and leverage over here. The first thing which we leverage is DRS, as I said before. We all understand and have agreed that DRS is the prima facie the tool or the feature which helps you move virtual machines within a cluster. And hence, workload balance essentially finds out a target cluster where a virtual machine can be placed and hands it over to DRS to make sure that it's able to place it in the most appropriate location within that cluster. Now, that's one part of leveraging existing DRS capabilities. When you're moving virtual machines across clusters, you might not just move the compute, which is mostly CPU and memory resources, but you might also end up moving storage. And this is a big change as compared to what it was in previous releases, is that we now allow you to move virtual machines irrespective of the fact if it's just a compute move or storage move. So we kind of move the whole virtual machine. So we can do a vMotion as well as a storage vMotion to move a VM from one cluster in, let's say, with a data store set to another cluster with a different data store set. Now, what this helps you do is that you're having a shared storage between clusters, which essentially is not a very good practice due to operational overheads, is no longer a requirement or no longer a foundation for you to move virtual machines from one cluster to another. So if you have storage DRS, then we leverage storage DRS, which you have by default if you have vSphere. We leverage storage DRS to ensure that we are placing those VMDK files or your data in the right location where it can get the best performance from a configuration or from an IOPS and space perspective. So those are the two benefits of leveraging DRS and WLP along with storage DRS to ensure moves of compute as well as storage. And this can be done within clusters and across clusters. So that's essentially how the whole thing works. Now, as I said earlier, you can not only do it manually, or you can do it manually as well as you can do it in automated fashion. Let me just jump a little deeper into how it works. So essentially, this feature of lights out data center automation takes certain input and gives you an output, right? Now, that input is usually a boundary of a data center or a custom data center. Now, this is important to understand. Imagine if you have a data center in your environment, and that data center has 10 clusters. So one vCenter, one data center with 10 clusters. Now, usually people have clusters or a number of clusters of smaller sizes, let's say 10 to 15 hosts, what I've seen mostly. And it's because of the fact that each of these clusters or group of these clusters serve specific purposes. I remember back in 2012 or 13, I wrote an article on purpose-built vSphere clusters. And that holds true today as well. People build up their vSphere environments and vSphere clusters, keeping certain use cases in mind. Now, I have customers who have a vSphere cluster for DNZ and a vSphere cluster for running internal production networks. Customers have external or separate vSphere clusters for licensing purposes. It could be Oracle licensing, Windows, or Linux licensing. They have different clusters for air-gap security for their networks, and hence they have different cluster sets. And they do not mix their workloads across on a single common cluster. Now, the notion of movement across clusters is scary, right? If you have a cluster, or let's say two clusters which are made for running Oracle virtual machines or Oracle database virtual machines, and you have a third cluster where you're running normal Windows virtual machines, you do not really want to move an Oracle database VM onto the Windows box or the Windows cluster. And you know the reason why, right? And cops will be standing outside asking for more license money. So essentially, we don't want to do that. And what we allow you to do with our placement engine is to create that boundary of where you want to move your virtual machines without breaking your policies or architectural decisions that you have taken for your environment. And hence, we allow you to introduce a concept of a custom data center. Now, that custom data center does not touches your vCenter or changes or creates a new object within your vCenter. A custom data center is a construct which you can create within vROps, and then you can pick up any clusters within a vCenter and add them to this custom data center. And once you do that, you kind of define a boundary or a logical group of clusters between which you're okay to move virtual machines. So imagine you have these two Oracle clusters which you have created, and now you want to leverage both of these clusters, and one has a workload which goes high in the daytime, and the other has a workload which goes high in the evening, and you want to kind of move virtual machines or balance virtual machines across these clusters. So you can create a custom data center, put these two Oracle clusters inside that, and start moving virtual machines within those clusters. And this can be done for n number of clusters. So you can create multiple custom data centers, and we honor or consider them as data centers within vROps. And we'll look at it when we go into the demo. Now, I spoke about, if you remember, I spoke about the policies piece. I spoke about the business and availability policies. And essentially what we do is we leverage all your rules which you have created within DRS or within vSphere. And we leverage and honor them to ensure that we are not stepping over certain design decisions which you have taken for your vSphere infrastructure. Things like reservations, shares, limits, resource pools, VPN configurations, low latency VMs, or affinity rules which you might have created for your virtual machine. We honor all of them to ensure that we do not move a virtual machine which might cause business loss to you because you never wanted that to move at the first place, right? So that's essentially what we do while checking this. Now, there are 100+ rules or compatibility checks which we go through before moving or suggesting a move to for a virtual machine, because what essentially we're doing in the background is making sure that we are not breaking anything which you have configured consciously to not move a virtual machine out of a cluster or out of its location. Maybe it's a given host or a data store. Now that's something which I will dwell upon as I move forward, and we'll talk about specific things which we take care of. Not all the 100, but some of the major ones. Okay, so now that I've given you an overview of what we are trying to do, let's just jump into how this WLP looks like. So I know the slide looks busy because of all those green boxes which have come up on top, but essentially what you're seeing over here is you start from the left panel where you have all your data centers, or you can have custom data centers, as I said, and when we do the demo, we'll see how you can quickly create custom data centers. And once you do that, you can go ahead and select any of your data centers or custom data centers based on their status of whether they're balanced or unbalanced. Now, on the left-hand side, you see the list of custom data centers and data centers. You see whether they're balanced or not under status. And once you select them, you kind of see the degree of unbalance which they have. At the same time, you see the number of vMotions which have been running within those custom data centers or data centers. And then the most important part you see in the center of the screen is what is the current workload visibility for those clusters from a CPU workload and a memory workload standpoint. Now that essentially kind of tells you whether any of these clusters, those are cluster objects, not hosts. So any of those clusters within those data centers are running out of resources or are running hot, right? And at the same time, it gives you a perspective of, are there any other clusters within that particular custom data center or data center which have resources available? And if that is the case, then why not leverage those resources rather than having my virtual machines to suffer because of shortage of or supply in this specific case, right? And in this case, it's memory supply. You can see between the East Management and East Comp, the East Management cluster is running hot on memory, while the East Comp has enough memory and CPU available for us to move over certain virtual machines so that they do not struggle with for resources. Now, that's what you can essentially do when you click the rebalance button. Now, we will look at this during the demo, but this is an overall how the UI looks like and what you can do. I spoke about the custom data center. So a couple of use cases is, let's say, keep tests separate from production, or test environment separate from production, do license separation. It's as simple as this. When you go ahead into the workload balance page, you click on that plus sign, create a new custom data center, and then you can choose any of the clusters within that vCenter, because vCenter is the boundary for the movement, and add them to that custom data center. And within a fraction of seconds, we start measuring the balance or start measuring the workload of those clusters to tell you whether there is an opportunity for you to go ahead and move workloads and create a better balance for your VMs to get appropriate resources within those clusters. All right, so moving on. I have had questions on this before, but essentially what we do is we kind of give you options here, and we give those options through policies, because we understand that every customer or every user of this particular feature and the kind of balance you want to maintain in your environment might be having a different set of requirements. So for instance, if you are a production environment running business-critical workloads, you do not want to run your clusters on, let's say, 100% workload. And hence, you would want to have certain cluster headroom available on all your clusters within a data center. And that cluster headroom essentially is the high water mark where you want to run your CPU and memory resources on within a given cluster. And essentially, we allow you to configure that for a given data center or a group of data centers using a simple settings button within the workload balance page. At the same time, we give you the opportunity to kind of take a stab at whether you want a lot of moves to ensure everything is balanced, or whether you're okay with the fact that till the time you're under your cluster headroom, you are okay and you don't want to move virtual machines just for the heck of moving them. So that's the balanced workload setting, which could be a conservative or aggressive, right in the center of the screen. And then the third one, so I'm kind of going from bottom to top, and the third one is consolidate workloads. Now, this is what we essentially leverage for some of our automation engines, which can go ahead and place virtual machines. I think I'll talk about this policy more when we go to the demo, and I'm sure some of this will be touched upon by Chad as well, so I'll not take his thunder and just move on. Now, this is a representation of what I meant in the previous on the previous slide. So you can see what conservative balance is, and as you move the slider towards aggressive, how exactly it will change. And it will basically change and say, I'm spreading workload across all your clusters rather than consolidating or densifying your clusters. That basically brings you to a use case where you can actually densify your clusters to free up resources. The second is moderate balance, where you loosely balance everything across, and you're just worried about the high watermark of your headroom. And the third setting is aggressive balance, where you want to tightly balance everything because you want to make sure that everything is utilizing the equal amount of resources across all your physical resources available. Those are the three options which are available within the settings. Now, I spoke about the headroom. Essentially, what you do is you go ahead and use the same slider to configure the headroom as to what free percentage of CPU, memory, and disk resources you want on your hosts within a given cluster or on your data stores within a given data store cluster. So that's the headroom, as simple as that. And then the workload score. Now, the workload score essentially is a known factor in vROps. So if you use vROps before, you have a simple slider which allows you to determine what your workload percentage among CPU, memory, and disk would be to take an action for a move. So for instance, if you're okay with the fact that you're 80% utilized, then up till 70-80%, we will not even recommend a move for a given cluster. We'll only recommend a move when it moves from that green zone to a yellow zone and starts or might create problems for your workloads which are running on that particular cluster. So that's what the workload score does. If your cluster is in a non-green state, then only the engine does something. Otherwise, it will not go ahead and move things around just for the heck of it, because we understand that moving a virtual machine, whether it's a vMotion or a storage vMotion, comes with a cost. And the cost of that move should always be less than the performance benefit which you will get from the move in order to make, or even before you make that move. So let me put it this way. You should only make the move if the cost of the move is less than the performance benefit which you will get from the move. And that's what we take care of with this simple setting which is available within the settings button, as I said earlier. Just to kind of explain that, you can see over here that I have a cluster, or I have two, cluster A and cluster B. One is, the cluster A is red at 95%, while the cluster B is at 70% threshold. This is the current workload. Now, if you see the policy, in the policy I've configured that any cluster will be considered for a move if it's 80% or more. So it'll be yellow on 80%, which is non-green, which you can see that cluster A is. The second policy which I have is the headroom, and the headroom is 10%, right? And it basically means that the utilization threshold is not more than 90%. Now, when I did the move using the WFB engine, you can see the after situation. In the after situation, we took care of both your policies. We moved cluster A or workload of cluster A as much as possible to ensure that it is having the headroom. The second thing which we targeted was to make sure that it's below that 80% threshold. However, while we were trying to do that, we found that cluster B was already at 79%, and hence we stopped, because if you remember, we do not want to move your problem from cluster A to cluster B. We want to make sure that we can help you as much as possible. And we stopped when cluster B was at 79%. So all these intelligent calculations are done in an atomic fashion, and you get that plan to go ahead and make a move, as I was talking about earlier. In a quick time check, okay. All right, so as I said earlier, you can go ahead and create or run a move yourself, or basically hit the rebalance button and move virtual machines, which we'll see in a couple of seconds, or you can also go ahead and schedule that for an automated fashion. It essentially means that I've understood the workload pattern, and I will move it on a given point of time, on a daily basis, on a weekly basis. Now, while scheduling is an option, I still believe that scheduling might not help all the use cases, especially if you do not have predicted workloads within your environment, which a lot of customers do not have. They have a mix and match of batch workloads versus something which is trending high versus something which is always jittery, and it all depends on what kind of applications you're running. But today, in a data center, you find all different kind of applications running in most of the use cases. And once that is the situation, you want a way to automatically detect a problem, and when the problem happens, you want to go ahead and ensure that the rebalance operation can solve that problem. Now, that's essentially what you can do with something called a workload balance alert. Now, you might be aware of the alerting feature of vROps, but what essentially we are doing over here is we are using certain computed metrics in the backend to measure the balance, or basically take all the policies that you have configured in your policy, whether it's workload to be 80%, at the same time the headroom to be 10%, at the same time ensuring that your VMs are getting the resources, and taking all those complex policies which you have created into a single metric or a single KPI. And that single KPI determines whether a virtual machine or whether a data center, or a custom data center has clusters which are struggling and they require a move. Now, essentially, they may or may not be struggling currently, but they're going towards that range, and hence you want to make sure that you can proactively move off virtual machines even before the problem happens. Now, what we do is we go ahead and give you this out-of-the-box notification or alert which tells you that your data center may require a balance, and that balance will help you relieve the resource utilization you have on one or more clusters. You have a couple of options. You can essentially go ahead and review the state of your data center by clicking the recommendation of review the workload balance container. This is the second option for you. But the first option which we give to you is to run the action immediately. So once you click on that run button, you will automatically be presented with a plan which can help relieve this workload which you're noticing in a given data center or given clusters of a data center. Now, you would say, Sunny, this is not automated because I would have to go and click that button. And essentially, if I've done clicking of that button 5 times and I'm comfortable with my policies and the moves which I have done in the past, the 6th time, I would want it to happen automatically. And we do take care of that and solve that problem But we do not do that out of the box because we want you to take that decision because it is your environment and you understand it the best in terms of what is the best for your environment from a perspective of when do you want to automate your decisions of operations. So this is not about the virtual environment metrics. We understand that. We understand the workload patterns, but we are talking about your business policies, your change management policies, etc. Hence, what you can do is the day you decide that you want to switch into a fully automated mode, you just go ahead and enable or automate the action, which is, or the alert which you get out of the box. So out of the box, the alert is not fully automated. Once you decide, you can come and go into the policy and change it to an automated action. As soon as you do that, you basically have given the full control back to workload placement to make these moves as the alert triggers or as unbalance is detected in your environment. So that's essentially what lights out automation use case is. All right, so again, I want you to feel comfortable of the fact that we do not make these moves with a blindfold on. We do not do that. And as I said, we do a number of checks. We kind of essentially go through certain things which are absolutely critical for your vSphere environment and the way you've configured your vSphere environment. First thing first, we all know that we can now move virtual machines across vCenters, but to be honest, the configuration of such an environment is not seen on a day-to-day basis, right? People are still working towards figuring out networks so that they can essentially move virtual machines across these centers. The good news is, and Jad and Simon have seen that at VMware, I don't know if others on this call have attended VMware, is that you can move virtual machines across your on-premise data center into VMware Cloud on AWS pretty easily, essentially because we do that with the NSX layer, enough of selling that. But we do not allow you to move virtual machines today across these centers, and that's the boundary of or supportability for configuration with workload placement. The second is when we do the compute moves. So when I say compute, I'm essentially talking about CPU and memory. When we do the compute moves, we take care of or we honor your availability and performance policies or architectures that you might have created. So stuff like DRS affinity rules, things like DRS anti-affinity rules. And if you have any of those configured, shares, limits, low latency VM settings, then we do not move those virtual machines or touch those virtual machines. The reason we do that is we know that you've configured those settings for a reason, and we don't really want to break that reason by moving around your virtual machines as we understand that you have a specific set of requirements for those VMs. So that's about the compute moves. In my opinion, compute moves are simpler. The problem which happens with storage moves. And if somebody comes and tells you that we will move your VMs no matter what, then trust me, you need to relook at that solution because data is anyways more important than the compute, because VM can power off in this entire operation while you were moving compute in the wrong way, and you can recover from it easily because you still have the data. But if you're playing around with VMDK files or storage without taking into consideration your availability policies and the way you've configured your architectures, then you are playing with your workloads. And hence, I would suggest that whenever you look into a solution which is talking about fully automating and moving virtual machines, then make sure that they do the following, which you see on the screen. Your source and destination data stores must be in a data store cluster because there should be a way or a technology which is guarding you against filling up a data store by moving multiple virtual machines onto it. For example, you have workload balance or a similar solution, let's say from the market, you pick up and you start moving virtual machines in an automated fashion. While you're making this move, somebody else is also provisioning a new or starts provisioning virtual machines on that particular data store. Now, if you do not have storage DRS enabled, then that user will have no visibility unless he's sitting with ESXi open and refreshing screens every 2 seconds to see if something else is coming, to what else is coming into that data store. And this might have happened with you a lot of times, especially with 2 admins working in the same environment. And hence, you want storage DRS or a similar technology to ensure that we are not stepping over VMDKs on each other and stacking up a data store to a limit where virtual machines can't even run their swap files and they die, or they can't even do any new I/O and they die. So at the end of the day, it's important that the storage move is measured through all these parameters, which I'm happy to say that we do, and then only recommend a move. We do not move VMs if they have RDMs available. If they do not have the RDMs available which they're presented to in the destination clusters, which makes sense, right? You don't want to move a VM and suddenly, oops, a partition is lost. We do not make moves if you have a virtual machine which is configured in a way that you have set up the VMDKs in different data stores. Now, this is a very common architectural practice amongst database servers where you want to spread out the VMDKs on different LUNs, different data stores, of different performance categorizations such as Flash versus SAS versus SATA, etc. And you do that for a reason. Now, we don't go and break that policy and move the virtual machine because we want you to show a green color in your data center. That's not the objective. We do not touch such virtual machines, but we work around them and find other candidates which can move to ensure that you get the performance, but you do not hit your availability policies. So those are some of the major things which you need to worry about when you're talking about moving virtual machines across clusters or across storage. All right, just a point of caution. If you decide that you do not want to move virtual machines or do data store moves because there's no requirement for you to do that, then we do give that control to you as well. So you can come ahead and select that you do not want to do storage vMotions. Hence, we'll only recommend moves where a virtual machine can be moved without moving storage. So we are assuming the fact that you have shared data stores across clusters. And if that's not the case, then you don't come and touch the setting. We'll do your storage vMotions as well. There's another advanced setting which I want to talk about is what do you want to move? When you are facing trouble or when you are about to face trouble, do you want to move your monster virtual machines, which are not monster from a size perspective, but from a perspective of utilization, the ones which are demanding more resources? Or do you want to move smaller buckets which are demanding less resources, but you can move a bunch of them to get resources available? So those are the 2 extra options which you have within the settings. And we look at them when we do the demonstration. I'll pause here and 35 minutes. So Jad, you're up next, but I would take any questions there on the chat. Do you have anything, Simon?
Nothing's come through from the everyone chat. I don't know if you've had any private messages.
While moving VMs across different clusters by vROps, there is no downtime. So that's a question. And can we choose which clusters can be a part of and which would allow that? So that question is from Faisal. I think, Faisal, I answered that question while doing my presentation, but just to reiterate, it's a zero downtime process because we leverage vMotion and storage vMotion, and you can absolutely create the boundary between which you want your virtual machine to move by using custom data centers within vRealize operations, and we'll demonstrate that. With that, I'll take a pause and a glass of water and hand it over to Jazz. Mr. Jad, are you talking about initial workload placement use case?
Yes, sir, and I will ask you to hit next when you're ready. All right, so quick transition here, but it's a similar topic, and well, it's actually building on top of everything Sunny just reviewed. And you know, the real automation doesn't just happen with the ongoing maintenance and day 2 of what vRealize operations does with all your workloads, but also when I add a tool or a solution like vRealize automation, or in this case, our cloud management platform, you know, where does this all fit into there? And the work that we've been doing for a couple of years now to increasingly integrate these products comes to fruition in about 2 slides that'll explain the whole solution. And really, thanks, Sonny, and really initial placement or initial workload placement is the integration between VRA and vROps in a way that the cloud admin, or neither the cloud admin nor the operations team have to really think about things like, where do I put these applications that get provisioned? What do I do when I'm at an alarm state with my reservations? And reservations, and for those familiar with VRA, are my sub-allocation of resources coming from the backend resource platform, in this case, vSphere. So what we've been doing over time is adding visibility into health metrics, increased integration via APIs, and so on and so forth. And in vRealize Automation 7.3, we've actually, we now identify and consume vROps as its own endpoint. So not just the metrics provider that it's been in the past to give me a health badge, but now it's an endpoint in that I'm actually doing some calculated decision-making between VRA and vROps. And it takes 10 times longer to describe this than it is to implement it. So to get to that real quick, really all we're doing here is handing the placement algorithm of application placements out, or taking it out of VRA and handing that to vROps, because vROps, as you've now learned, knows a lot more and about the infrastructure and can very intelligently tell VRA where to put a given application. So I'll walk you through a scenario. We've got our cloud admin, and we've got our consumers, and we've got our operations team. Let's just say these are different folks. In some cases, they are the same people. So the cloud admin comes in. Actually, Sonny, if you can just go to that previous one, let me just make one quick statement here. Previous slide. There we go. So the cloud admin opts into this capability by, first of all, we'll create several reservations. Reservations are my landing zones for applications, and those are aligned with what's called a business group. So if you're familiar with VRA, all that makes sense. If you're not, we'll send you some more resources after this call, or you can do some Q&A, and we'll dig a little bit deeper if needed. But anyways, the cloud admin or the tenant admin or infra admin in this case will opt in by saying, hey, use vROps placement policy instead of my own. Okay, that is, we'll set up an endpoint and we'll opt in using that checkbox. Now, it is an all or none, but it doesn't mean that it's always going to be a vROps-driven placement policy, because in some cases there is no other option than the one vSphere cluster, and I'll expand on that next. So let's go ahead and go to the next slide, and then I'll walk you through that workflow and what it looks like. So what happens is my developer, in this case, Scott, comes into the VRA catalog and requests an application. Now, what would typically happen is that application, maybe the request gets approved or goes through governance, but regardless, what VRA will do to place that application is say, okay, well, where is Scott? Which resources are entitled to Scott? And that happens in this reservation construct based on Scott's business group membership. VRA says, okay, there's 2 reservations. Both of these reservations happen to meet all the requirements of the application, and that could be a specific storage, a specific network, or even a static placement through a policy. So what vROps will do then is say, well, I provisioned to reservation A last time. I'm going to just go ahead and provision to reservation B. And that is the fundamental placement policy in VRA. Now, it gets way more calculated than that. As soon as I start using capacity and start using specific resource requirements, VRA will do a little more intelligent placement, but not at the analytical level. So what we've done is we now, starting with VRA 7.3 and VRA 6.6, we now opt in, and VRA says, okay, Scott has 2 vSphere-based reservations that happen to be tied to 2 or more vSphere clusters. Okay, And instead of making that round-robin placement policy or that very basic placement decision, he's just going to hand the request off to vROps. And VRA is going to say, hey, vROps, you know what's up with these clusters. Where should I place this application? So I'll do my initial check. Can you meet all the resource requirements? And if yes, I'll hand those candidates over to vROps. vROps will assess those candidates, and those candidates are the reservations that are available to the user, okay? Because vROps doesn't have that visibility. He only understands the vSphere cluster. I'll hand that over to vROps. vROps will say, okay, let me see. I'll assess vSphere cluster 1, vSphere cluster 2, based on all my analytics and based on the policy that you, the operations admin, have determined that your business needs. So the balance and what is your placement strategy? What are you trying to accomplish out of it? All of what Sunny has discussed already applies. And vROps will respond to VRA and say, you know what, I recommend putting it on cluster 2. He'll hand that back over to VRA. VRA will note placement on cluster 2 and then go ahead and provision the application onto cluster 2. Now, this happens in about a second or less, that the whole decision, all the algorithm, everything happens immediately. In VRA, when you put in the request, you can watch that decision happen in your execution plan. So you'll click on the request and you can see the status of the execution. It'll say, hey, I've made a placement decision. It'll actually show you what were the candidates, where did you decide to place it, and it'll spell it all out. So it's really cool. The point is, it's not supposed to be sexy. It's not supposed to be anything advanced or mind-boggling or mind-blowing, right? It's supposed to just happen. You have these tools available to you. What we are focused on is just leveraging those analytics. So VRA is going to leverage vROps analytics, and he's going to come back. Now, all of that happens in flight. All of that happens in a matter of seconds, and then VRA goes off and does its thing. From that point forward, vROps will continue to monitor the balance of the infrastructure and the balance of the clusters. VRA has been trained to tolerate changes of virtual machine placement across the clusters based on vROps. But now it won't do it unless it's specifically allowed to do it. So I'm not going to move a virtual machine on cluster 2 that is leveraging resources that my consumer specifically is entitled to a cluster or a data store or anything like that that's not part of that user's reservation or is not part of a policy or reservation policy that that application belongs to. So while all of that in initial placement matters, what vROps does with the application post-provisioning also matters, and we respect all of that. So vROps will not move the machine into out of sight or break any VRA-specific policies, even if there's a specific policy in vROps that says move this in a contention situation, et cetera. If VRA owns that machine and has a strict policy of the resources that are available to the user who owns that machine as well, vROps isn't going to override that. It sounds way more complicated than it is, but all you have to know is when I request a machine, it gets placed intelligently by vROps to available resources, and it continues to be managed based on the policies at play. Okay? And another part that makes this happen, if you want to go next, Sunny.
Trying to. There you go.
All right, and in vROps 6.6 and higher, we're going to leverage the vRealize Automation Management Pack. Now, this is an out-of-the-box management pack at this point. So you're going to do two things. In VRA, you're going to configure the ops endpoint and your metrics provider. That's just for everything that's existed in the past. In vROps, you're going to create your workload balance policies, and you're going to configure the VRA management pack. You no longer have to install the pack and set it up from Solutions Exchange. It's all built in, and they are designed to consume the APIs that are available in these two latest versions, so VRA 7.3, vROps 6.6. In addition to this, and we decided not to show that slide, is the SDDC management dashboard. That's a different topic, but that's another way of gaining visibility into what vROps and VRA are doing together. That is a free download from the marketplace as well. Okay, and then so if you invoke a change from the ops side, Most important thing is we want VRA to either block it if it's not allowed, or at least be aware of it, so that this integration ensures that that's the case. So you can take any questions to the chat. That's it. That's what I wanted to share with you guys. There'll be a lot more content out there being published pretty soon in the next couple of weeks on more deep dive into what's happening behind the scenes here. And this is all part of a presentation we did at VMworld that's also going to be published. It's called Operating Automation Environment. So it's there's a lot of good content TBD.
Awesome.
And
awesome.
I'm going to stick around and answer questions. Thanks, Sunny, and thanks for everybody.
Thank you, Jed. Thank you. That was wonderful. I knew only you could do justice to all the hard work which both the products have done to make sure that they can talk to each other in an intelligent way and solve use cases for each other. It's awesome. All right. So traditionally, this is what we do. We do a demo. So let's see. We have 3 use cases. We'll try to cover a couple of them within a live demo and see how it goes. Last time I did a demo of workload balance, somebody actually balanced my data center well enough, and I could never get a recommendation for any moves. But this time around, I hope there is enough unbalance in my environment. Okay, so what you're looking at is vROps 6.6. If you've not played with it or installed it, I would highly recommend that you upgrade to 6.6 or download a copy, evaluate it, because it's miles ahead of what 6.5 was in terms of content, in terms of user interface and experience. And as I said, there's a brand new feature of workload balance, so you don't have to actually fetch it from anywhere else, but it's right there on the home page. And this is where you can get a workload balance from. The other place where you can get it from is through dashboards. And essentially, we have built a getting started page for you, which essentially helps you go to workload balance and achieve the same result. I would like to go from home itself and just click on workload balance. And once I do that, essentially what is happening over here is I'm demonstrating in terms of what's going on in my environment. And you can see, as I stated earlier, I have around 5 data centers in this environment, and these 5 data centers are being measured for balance based on the policy which Chad was talking about a minute ago, which we have configured for them in order to detect any kind of imbalance and either manually or in a fully automated way fix that imbalance to ensure that the application performance is maintained and they're not impacted by any kind of bottlenecks which are there on the infrastructure level, either from a CPU perspective, memory perspective, or storage perspective. That's essentially what it does. Now, as I step through my data centers on the left, you can see that I'm demonstrating the clusters within those data centers. And these clusters are essentially showcasing a couple of things. One is the CPU and memory workload of those clusters as you see them right now. And at the same time, you see the DRS settings on those clusters which I spoke about. So at this moment, you can see that the DRS settings on the management and the management core clusters is set to fully automated and at most aggressive level from a DRS standpoint. And that's all the visibility which I was talking about, which you can get from each and every cluster on a single page. Whether you have 100 clusters or 500 clusters, you can simply step through and check the settings of those clusters through vROps. There's also a dashboard which highlights if your DRS configurations are not, or if you want to really just get a quick glance of how your DRS configurations are, and it's called a cluster configuration dashboard. We'll talk about that some other day. But if you scroll down further, you essentially see how your workloads or how your resources are being utilized from a cluster, host, virtual machine standpoint or resource pool standpoint, whether they're highly underutilized or highly overutilized. And you can see that certain clusters over here are highly overutilized from a memory standpoint, while there are others that still have resources available. So this kind of gives you a map of how and your workloads are distributed or how your infrastructure is being utilized. Now that's kind of gory details, but even before we go there, I have a simple use case which I spoke about earlier that, and Faisal asked about on the chat as well, that can I limit the boundary of where the virtual machines should move? And here comes the concept of custom data center, which you don't see over here right now. I do not have any custom data centers. So imagine that in my environment, I have 2 clusters across different data centers maybe, and these 2 clusters are designated for moving Oracle virtual machines or hosting Oracle virtual machines, and these are Oracle database servers. Now, what I can essentially do is to save on my licensing costs and not move Oracle database servers across my data centers into different clusters and get into trouble, I can essentially go ahead and create a custom data center where I can create my moves. So I could go ahead and quickly click on the plus sign. So just go back again, click on the plus sign right over here to add a new custom data center. And let me call it the Oracle DC. And this is CDC, or custom data center. Now, as I told you before, the boundary of workload placement is a vCenter. So while you get presented options of creating a custom data center across vCenters, you do not choose that when you're trying to use custom data centers for the use case of workload placement. Now, custom data center is just not restricted to this one use case. You can have a use case of a custom data center for doing capacity planning, for example, across site clusters or across vCenter clusters if you want to, and we completely support that. Now, in this case, coming back to the placement algorithm or placement use case, I can go ahead and go into, let's say, MSBU East data center or VC East data center, and imagine I had 15 clusters here. I can just select, let's say, these 2, which are, imagine the Oracle clusters, or the clusters which are hosting the Oracle workloads, and click on OK. And as soon as I do that, you can see I have a custom data center created, and which is called Oracle DC. If I go ahead and refresh the page, I have immediately calculated whether the clusters within this custom data center are in trouble or are they working fine. And you can see that I have 2 clusters. One is the East Comp and East Management, which we consider as 2 Oracle clusters within a data center. And what is their current CPU and memory workload? And are they breaching any of the policies from a workload standpoint? Now, you can see that my East Management is orange on memory workload, because it's way higher than my default policy of 80%. Now, even before we go ahead into rebalance, let's just quickly look at the first use case. The first use case is where I can go ahead and configure any of the DRS settings or review or configure. So just step through. I think everything over here is fully automated, or DRS is enabled. But essentially, if you pick up, let's say, imagine a cluster or a data center like this, you can go ahead and select a cluster and set the DRS automation level. Now, what we are essentially doing is leveraging the vROps actions framework to go ahead and talk to vCenter server and do any kind of actions, such as changing the automation level of your DRS on a given cluster. So you can disable it, make it manual, partially automated, or fully automated, or change the threshold from most conservative to most aggressive. And these are settings which you can do right from the screen itself. So imagine I'm just changing this from most aggressive to aggressive, and I click on Begin. What essentially it's doing is going ahead and taking that action to go ahead and change that setting for that specific cluster. And any changes which you're making through the automated action frameworks within vROps are actually tracked within a recent tasks. So I can go ahead and click on recent tasks, and it will take me to what I'm doing right now. So you can see that I did change the DRS automation on the 5th, or this cluster, East Management, and currently I just changed it for the demo ops 2 cluster, and right now it's in progress. So you can see, in fact, it's just completed. The status of the call which we made is just completed, and we're waiting for the results to come back from VC. We track it event by event as those events are created in vCenter. So you can see now we are starting the action and to go ahead and change that particular setting and modify it. And once that is completed, in the next collection cycle, we'll get a return of whether that action was successful or whether it failed. And that's how we go ahead and make changes to your DRS right from here to ensure that your DRS is configured the way you first created and architected it for. And if there are any configuration trips, then we highlight that to you immediately through the use of the workload balance page and the additional dashboards which are available within vROps. Now, going back to our primary use case of the Oracle workload. So let me see if I can go ahead and get a plan today. Otherwise, Chad will kill me. So let's see if so that's my DRS settings. The second thing which I do is kind of look at the policies. So when I go ahead and click on settings, there are 3 policies or 3 knobs which are available over here. The first one, the first slider is around consolidate workloads. Now this is where I was talking about the use case of densification in terms of how you want to go ahead and run your clusters. So on the graphic on the right is actually clusters and how you want to run your clusters. Do you want to densify them by moving all your workloads onto lesser clusters? Imagine distributed power management working along with DRS. Or do you want to spread out the workload by using the setting of none? And that's what it will do in terms of placing virtual machines. The second option is around balanced workloads. Now, this is pretty critical. This essentially, and when I move this graphic or move the slider, you can see how the graphic works. And if I'm on a conservative level, I would only make moves or recommend moves when there is a resource contention. I will not just move because I need to move and try to keep things balanced. Now, that's how the conservative approach works. It basically takes 2 things into account: what your configuration or headroom is, and second is what is your workload percentage high watermark is. And that's pretty much it, aggressive or conservative. And then the third and the most important thing is giving you the control of ensuring that you're able to determine that what kind of utilization you want to drive within your environments. You might have a production cluster where you do not want to really step up the gas of more than 80% workload for a memory standpoint, because you know that you're running Java applications there, and you cannot really go ahead and put them in trouble just because you want to drive higher utilization. So you might want to cap that cluster or that particular data center at 15% or 20% resources. Now, that watermark automatically allows us to determine how much we can pack your clusters so that we do not run out of resources or do not create a situation where you're facing performance issues. So that's the headroom setting. And once you do this, you click on Save, we basically go ahead and run that setting or configure that setting for that cluster or that data centers which are included in that particular cluster. Once I click on Yes, that policy is configured for me, and that policy is now applied to recalculate any kind of rebalance which is required for my objects in my custom data centers or data centers. Now, I do have, let me just quickly check in, okay? I do have a place where I have not moved virtual machines. I want to check if I can get any recommendations. Let's try that on the Oracle data center. So some of the reasons I do not get placements is because I do not have common networks in some of my environments across, and we take care of that, right? We take care of making sure that we have common networks across clusters. If you do not have common networks, then you are jeopardizing the network of your virtual machines when they move across to a different clusters. So since this is a lab environment, we only have that configured let's say in this particular environment. Now, here the settings are conservative, and when I go ahead and hit the rebalance, I do have an opportunity of improvement. Let's pick up another example. I think this guy, happens to me every time I want to rebalance. Yeah. I think it's only this guy that has an opportunity. So let's look at this. All right. So I have two clusters where I can move virtual machines across, and what I will receive before and after I make those moves in this environment. So you can see that I'm set up to aggressive level, and what I'm trying to achieve over here is that my memory workload and CPU workload is as distributed as possible. And after I make this move, the before situation is that one of my cluster, which is demo auto, is running on 45% memory workload, and the demo ops is running on 56%. And in this case, I have 50% memory workload on 50% once across the second cluster as well once I make the move. So you get a before picture and an after picture in terms of what we're doing from a CPU standpoint, memory standpoint, and storage utilization standpoint. Because once you move virtual machines, you might go ahead and move storage along with it as well. If you're doing that, then we tell you what will be the end state of that storage, keeping everything into consideration. Now, in this case, I have a shared LUN across these clusters, and hence you can see that I do not require a storage move at all. So I think I'm getting a nice message of telling me, hey, you can move virtual machines from one cluster to another, from demo ops to demo auto, or from demo auto to demo ops. And in this case, we are just trying to make sure that we can get you the best balance by moving virtual machines across clusters. And these are the three VMs which we are going to move. And once I go ahead and click on begin, I'm essentially going ahead and activating the workload balance engine using the algorithms which will help me to start placing those virtual machines based on what I have calculated. As usual, I can go into the recent tasks, and I can go ahead and check what happened to my rebalance container action which I just executed. Now, whether you're doing executions manually through the rebalance button, or you're doing executions in a fully automated way, in both cases, all these actions are tracked into the recent tasks, and you can essentially set your policies in terms of what kind of recent tasks or how much time duration worth of recent tasks you want to retain in your environments. You can export those if you want to, so that you can go ahead and parse them and understand what actions were taken for a given time period. You can export one or all of them. You can filter them to understand if there were certain actions which were completed or failed, or they were partially successful. Now, you will also see partially successful actions because while we gave you the move or the recommendation of the move, we noticed that, or when we were trying to actually make the move, there was some failure which happened because at the vSphere layer itself, because of which the move could not complete. And that's where we would come back and tell you whether a specific move was not successful because of a failure which has happened in your vSphere environment. And you will see all the events as you see in your vCenter server being populated on the screen itself. So that's where you do the manual moves. Now, if you look over here, I've completed the move of my virtual machines. In fact, I've completed all three of them in this particular case, because just a vMotion, it happens way faster as compared to the process of storage vMotion. So, and that's essentially what I wanted to show you in terms of how you can go ahead and start from assessing all your data centers or custom data centers, and then go ahead and complete that by moving virtual machines in an automatic fashion or a manual fashion, depending upon how you want to go ahead and achieve balance. I do want to go ahead and show you the alerts or the alert which I was talking about, and how you can go ahead and configure it. All right. So these are the alert definitions which are available within vROps. And you have alerts which are configured. So you can see you have alert says data center may require rebalance to relieve heavy resource utilization in one or more clusters. I edit this alert. You can see that I have an action associated with this alert, which will go ahead and run the rebalance if I click on this button. But if I want to fully automate this, I can go into the policy and change this alert action to fully automated as I showed you earlier, and your action will automatically trigger every time you see a problem, and the rebalance will happen automatically without you even knowing. You can simply report that to recent tasks to understand how many moves have happened on a day-to-day basis to ensure that your virtual machines are receiving the performance guarantee which you have configured based on your business policies or availability policies. All right. With that, I have a couple of more things to talk about. One thing is to summarize. So essentially, the automated workload balance is giving you an insurance policy, making sure that you can mitigate any kind of risks in a fully automated manner rather than you having to do it manually. It gives DRFs and storage DRS to do what they're best for, to place a virtual machine within a cluster or a data store cluster. And as I said, you can do it manually through dashboard or alert. You can schedule it, or you can do it in a fully automated fashion via alert itself. Let me just go ahead and quickly, which I did not touch upon, is schedule. I go ahead and close the workload balance. Once I've made a move and I'm happy about it, I can go ahead and select that cluster or custom data center and go ahead and schedule that and give that schedule a name, run it on a different time zone, and do it indefinitely if I want to. I never expire it, or I can expire it on a specific date as I would like to ensure that I can run this rebalance as and when it's required. So I'm doing it daily, and I'm expiring it on, let's say, September 30th, and I save it. Once I save it, that schedule is saved, and this rebalance operation will always happen or run every day at the given time period. You can create as many schedules as you want, but I think once you've achieved rebalance by using manual methods of alerting or dashboard, then you can actually start to fully automate it by using the alert mechanism, which is available with vROps. With that, I would pause. A couple of more things around where you have all the episodes of vROps webinar series. So we did refer to some of the previous episodes today. And if you want to go ahead and watch some of those previous episodes, you have the links right over here. All these presentations are for you, so we are not just giving you the PDF files, but you get all these presentations in a PowerPoint mode. So feel free to get them, use them, share with your colleagues, and if you have any questions while doing that, then feel free to reach out to us. One request is that we do want, so any recordings which we are going through or which we are doing is all available on our blogs. We have virtualjad.com from Jad. That's his blog. I think it's top 25. Jad, have you made top 10 yet?
No, not yet. Maybe next year.
Next year, okay. He'll move to top 10 and give me top 25, and Simon would move into top 50. That's the plan. So that's our blog, and you can refer to them and get all these materials which we are talking about, recordings as well as some great stuff on VRA from Jad out there from our blogs. And all we want at the end of the day from you is feedback through the survey link. We'll put the survey link on the chat window. Let's just do that quickly so that helps while it's fresh. And please pick it up from the chat window, share your feedback so that we can improve on what we've done so far and can give you better results or better topics in the upcoming sessions. With that, I would pause and would take any questions either through the chat or through the phone line, either for Jad or myself. Feel free to ask any questions. Anything you have, Simon, on your chat?
No, it's fairly quiet, mate.
Awesome. What about Jad? Do you have any direct questions you want to talk about?
Nope.
Okay.
Everyone's still in post-VMworld mode.
Okay, cool. All right, so I think we've covered all the questions and we're right on the time. So I would want to close this out today, and feel free to share your feedback on the survey link which I've just shared. And we'll be coming back again with the next episode pretty soon and talking about some more cool stuff and use cases around operations. Thank you so much, and you have a great day. Thank you, everyone.
Awesome.
Thank you.
Thanks, everybody.